At the end of this video, you should be able to recall concepts of polynomial functions, enumerate properties helpful in graphing functions, and determine the end behavior of a graph. Let us now recall the concepts of polynomials. Given the equation x cubed minus 2x squared minus x plus 4, the degree of a polynomial is the highest exponent seen. In this case, it's 3. The leading coefficient is the first term in a polynomial. For this example, it's 1. The constant term is the term without a variable in a polynomial. Number 4 is the constant term. The rational root theorem helps us know the roots of a given polynomial. We use L over f wherein L is the constant term and f is the leading coefficient. We also get the possible factors for L and f. So in this example, L is 4 and f is 1. Factors of 4 is 1, 2, and 4. As for 1, the factor is just 1. We use synthetic division to check the factors.
What is the maximum turning points of the equation y equals 3x raised to 4 minus 2x squared plus 3? The maximum turning points is 3. We look for the degree and use the formula n minus 1 wherein n is the degree. Describe the end behavior of the graph of the polynomial function y equals negative 3x raised to 6 minus x cubed plus 3x squared plus x plus 7. The degree is 6 and the leading coefficient is negative 3. Since the degree is even and the leading coefficient is negative, y approaches negative infinity as x approaches negative infinity, and y approaches negative infinity as x approaches positive infinity. How is the graph of a polynomial function with odd multiplicity differ from the graph of a polynomial function with even multiplicity? If the factor is a zero of even multiplicity, then the graph touches the x-axis and turns around at that factor. This happens because the sign of the function does not change from one side to the other side of the factor. On the other hand, if the factor is a zero of odd multiplicity, then the graph crosses the x-axis at the factor. This happens because the sign of the function changes from one side to the other side of the factor.
The degree of a polynomial is the highest exponent in a polynomial equation. The constant term in a polynomial is the term without a variable. The rational root theorem helps us identify the roots of a given polynomial. We use L over f wherein L is the constant term and f is the leading numerical coefficient. To get the maximum turning point, get the degree of a polynomial. Use the formula n minus 1 wherein n is the degree. The end behavior of a graph depends on its degree and the leading numerical coefficient. There are 4 cases. If there is an even multiplicity, then the factor would be considered a turning point. If there is an odd multiplicity, then it would just cross the x-axis.